Okay, this is lesson 63. It's going to be more arithmetic sequences. We're just taking a little bit at a time, kind of starting out slow so that you don't have a massive amount of notes. So we're on 146, 147. And it's 63. More arithmetic sequences. Okay, the first part we're going to do is, if you remember in lesson 62, we mentioned the explicit formula and said that the explicit formula was formatted from this, and then we could clean it up because we've got several of them. We did them. We got the a sub n equals 16 minus 9n for this one, and we got a sub n was, let's see, where was this one? Negative 43 plus 7n, and then the last one was a sub n is 1 plus 4n. So in this case, we're going to actually give you that formula. So given the explicit formula, okay, we want to do two things. We want to find the, let's see, I think it asks for the first 5 terms. And it asks for the D. Okay, so let's let our formula be a sub n is equal to negative 32 plus 6n. So if I want the first 5 terms, I'm going to do a sub 1, and I'm going to actually go through the arithmetic. You can probably do it in your head or with just a calculator, but a sub 1 would be negative 32 plus 6 times 1, a sub 2, a sub 3, a sub 4, a sub 5. And you should be able to figure out what your D is, and once you do that, you may not even have to do all the patterns here. So negative 32 plus 6 is going to be negative 26, and then a sub 2 is negative 32 plus 6 times 2, which is negative 20, because you got negative 32 plus 12 is negative 20. Then the third term is a sub negative 32 plus 6 times 3, which is negative 32 plus 18, which is going to be negative 14. Do you see what your D is? You're going from negative 26 to negative 20, which if you do negative 20 minus negative 26, you've added 6. You've added 6. So you can either put 4 in right here, or you can simply add 6. If you've done enough of them that you feel comfortable that your arithmetic's right, you're going to get negative 8. And then when you add 6 again, you're going to get negative 2. And there's your first 5 terms. And we've answered the question, what is the D? Now, I want you to look at this and look at the relationship with the equation. Could we have seen the D? Is that just a coincidence? And actually, I think if you look back at the ones from yesterday in the last lesson, you notice that here, when we were doing, let's see, we had our D was negative 9 here, and this was in number 2. You had our, we were adding a negative 9. We put negative 9 here, and then we cleaned up the formula. Look, the coefficient of the n was the negative 9, which was the D. And so that's not just a coincidence, that is actually the number that is going to be increasing or decreasing by. In this case, it's going up by 6. So that's number 1. And let's do one that's, let's see here. I've got number 2. Let's say a sub n is equal to 22 minus 20n. And I've got D should be my negative 20. We should be going down by 20. and we'll check it when we plug our numbers in. And then let's do a sub 1, a sub 2, 3, 4, and 5. And let's see if that's our pattern. So once we get our first term, it should be pretty easy. So you've got a sub 1 is equal to 22 minus 20 times 1. So we're finding first term, put the n here, 1 here, 1 here. 22 minus 20 is 2. And we should be subtracting 20. Let's see, 22 minus 20 times 2, that's 22 minus 40, which is negative 18. You've got a sub 3 is going to be 22 minus 20 times 3. That's 22 minus 60, which is negative 38. Do you feel comfortable enough that we can just go minus 20, minus 20, minus 20? It's going to be negative 58. Minus 20 is going to be negative 78. So that's a pretty easy set of problems. I mentioned to you just a little bit in Lesson 62 the idea of the recursive formula. And a lot of people want to make more out of this than what it is. It's simply, you know, if I take a sequence like, let's say we have 5, 8, 11. I think that's when we had in Lesson 62, 5, 8, 11, 14, dot, dot, dot. Then the recursive just says that you're adding 3 every time. You're just taking that constant difference and it's just saying I'm going to adding 3. Now the reason we don't like this, because if this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5 is easy. It's 17. But if I want a sub 50, then I got to keep adding 3. But you want to know what it looks like. And it looks kind of weird, but I want you to look at some terminology. If this is a sub 1, and this is a sub 2, and this is a sub 3, a sub 4, then think about it. A sub 2 is equal to a sub 1 plus 3. So you take the first term and you add 3 to it. So first term was 5. 5 plus 3 was 8. And then a sub 3 is equal to a sub 2 plus 3. Now, when you do that generically, instead of putting, you know, if you're wanting the 50th term, then instead of saying a sub 50 or a sub 20, kind of like we were doing a while ago, if we set those up with n's, then we can say, as we come down our list, we can say make sure I'm on screen. We can say a sub n, okay, now look at your numbers. How are these two related? Is equal to a sub, now if this is 3 and that was 2, if that was 2 and that was 1, notice we're going down 1. So if this is n, if that's 50, then this would be 49. So it's going to be n minus 1 plus 3. Now that's the recursive formula. And that just simply means that whatever term you want, you have to take the one in front of it and add 3. That's all that's saying. Let's try one. I guess I better go to the top of the next page. Okay, number 3. Okay, I'm given the recursive formula. Let's say a sub n is equal to a sub n minus 1 minus 12. Okay, and they give us that the first term is 32. Now they have to give us that, because if we don't know the first term, then it's very difficult to find the next ones. And if I want to find the second term, then I would simply take the first term and subtract 12 from it. So that would be 32 minus 12, which is going to be 20. A sub 3 is a sub 2 minus 12, which is equal to 20 minus 12, which is 8. if you write it out as a sequence, this is, a lot of people, this one freaks them out, but it's all we're saying is what you've always done with a sequence. It's like, well, they're just subtracting 12. So if the first term was 32, the next one was 20, the next one was 8, subtract 12, you get -4, subtract 12, you get -16, and so on, if it asks you for the terms. Now, what if they ask you for the D? Okay, the D is, what are we subtracting every time? We're subtracting 12, so -12. And then what if they ask me for the explicit formula? Now remember the difference? Now this is the one we like better because we can find, you know, it's okay if I want 1, 2, 3, 4, 5, 6, but if I want a formula, if I want a term way out there, I don't want to have to keep subtracting 12. So let's see if we know what we need to know. A sub n equals a sub 1 plus n minus 1 times d. Now remember, when you're doing the formula, you're going to leave these blank. You're going to leave those as your variable. Not necessarily blank, but you're not going to put a number in. So you got a sub n is equal to the first term, 32, plus n minus 1, and we knew our d was -12. So a sub n is equal to 32 plus, distribute, -12n plus 12. 32 plus 12 is 44 minus 12n. Now, it definitely looks different from our recursive formula, but notice that if we want to know a sub 1, which we already know what it is, put a 1 in. 44 minus 12 times 1, which is 32. A sub 2 equals 44 minus 12 times 2, which is 20. See, we're following the same thing. This one is great because if I ask you for, and I think in this case they asked me for a sub 52, then I'm going to do, here's my formula, I'm going to do 44 minus 12 times 52, and I definitely need the calculator for that one. And I've got, I don't know if you can see it, I've got 44 minus 12 times 52, and I got -580.